S ブースター2022最終選抜会プレゼンテーション再開となります。No.8 EDWAR プレゼンテーションタイトルは Ocean Eyes です。オーシャンアイズチームはインドネシア出身の2人のメンバーで構成されています。リーダーのエドワーはテレコム大学で講師を務める傍ら、衛星通信レーダー研究所の研究者でもあり、超小型衛星のサブシステム及びミッション開発に取り組んでおり、ガルー・マーリアンシャーは組み込みデバイスの開発に経験を持つフリーランスエンジニアで、2015年にインドネシア国立航空宇宙研究所ラパンが開催した大気球ペイロードコンテストで優勝したことがあるというチームです。それではスタートお願いします。Please start your presentation.
Good afternoon, ladies and gentlemen. My name is Edward. I am from the Ocean Eyes team, Indonesia. Here, I will present our innovative idea that is provided by me and my friend, Galuh Mardiansyah. My family really love sushi, one of famous food from Japan. My son, especially, they love fish roll sushi. Most of ingredient of sushi is coming from the ocean. Talking about the ocean, my country, Indonesia, its 2/3 area is covered by the ocean. There are million people in Indonesia earn a living from the ocean by becoming a fisherman. According to our ministry data, they are able to provide $1 million revenue from their activity. However, they actually not have proper management to plan and do their fishing. The main reason is because they do not have any information about where is the good fishing spot. So they usually waste their resources as fuel to find it. Once they find it, they will over-exploit it, and it's causing overfishing in some area in our ocean region. In some extended cases, they are also ruining the ocean ecosystem. So here, we are coming up with an idea to combat this problem. It's an integrated system that will provide information about where is the fish population, location, and its condition. We call it Ocean Eyes. Ocean Eyes consists of two main parts. First, the smart buoy and the application. The smart buoy has sonar sensor, proper independent power, and communication. It will be the eyes that will see the fish population underneath it, and the application will be the interface between the user and the buoy. This is how our buoy works. It will detect the fish thanks to the sonar sensor, and then it will send the data through the satellite network. The satellite network will down the data to the command center. The command center will collect the data from all the buoys, and then it will display it into an interactive map in our application. In this application, it will show where the spot that has a good fishing spot and where is the place that has critical fish population. It will show any other properties in it. Our main user is the ministry and the fisherman cooperation group. But this is our subscription plan, even though our main target is the fisherman cooperation plan and the ministry, but actually every fisherman can access this application, but it will only show where is the forbidden area to fish. Our spirit is to combat the overfishing together with less cost. This is our first prototype that we have done so far. We've built our first buoy, and it can detect underwater objects such as coral. And this is also our first application that can show the properties of detected object. We want to upgrade it into something that we're presenting now. So this is our plan. We want to go completely in 2024. So next year, we want to deploy our first pilot project. We want to test our hardware and software. We also want to collect some funding to support our activities. By using this ocean ice, we believe that we can help the fishermen to manage their fishing activity better by knowing where is the good fishing location. And we believe we can help them to increase their prosperity by doing the activity more effectively. And we also believe by knowing the condition of fish population, we can preserve the fish population, and it's in line with one Sustainable Development Goals number 17. Number 14. Thank you very much for your attention. Ocean ice, the bridge of the ocean and the human. Thank you.
Thank you very much for a beautiful presentation. Thank you so much. それでは質疑応答の時間に移りたいと思います。ご質問のある方は挙手をお願いいたします。So please, Ms. Lola.
Yes, I'd love to see your evolution and how you're continuing to grow and evolve, and look forward to what's next.
Thank you very much.
Yes. Question is around funding. So how much are you looking for, and how would you deploy that capital? And I have one other comment after your comment.
Thank you very much for your question. On the first batch, actually our capital for one buoy is around 150 until 1,500 US dollar. It's for one buoy, and for one batch we need 200 buoys. So it's like we need around 1 million something to operate it and to add human resource to design and to deploy it.
Great, and then I think there might be a pivot coming up around that as well.
Thank you very much.
One of the things too is Helianti Hillman from Javara and others are doing some really amazing things. So maybe we can talk after if you're interested.
Thank you.
Thank you very much for a great question. それでは夏野様お願いいたします。
So I'm not sure. I'm wondering how accurate you can sense the fish, because from the buoy, you know how you sense. You know, it cannot reach too far. And the fish is moving so fast, right? And the second question is, how much density you need to cover some area of sea. The buoy distance.
Thank you very much.
Should be very close.
Thank
To
you
get
very
the
much
accurate data, right?
Thank you very much for your question. For the first question, in order to detect the fish, we have tested our sonar sensor. It's actually able to detect one fish by using one sensor, but we believe that the fish in the ocean, usually they move together with their group. So it will be much easier for our device to detect them. And for the second question, how much minimum buoys that we need to cover, let's say, for example, Indonesia ocean region. Indonesia has about 90,000 kilometers of coastal line. So at least from our rough calculation, we need about 600 buoys. But it will only create one detection line, but it will be good if we can create more detection lines, such as I can assume it is like Starlink in the satellite, but we put it on the ocean.
But in Japan, the ships, all the fishermen are using sonar from their ship.
Yes.
And it's much cheaper than set up a buoy network, right?
So
the cost efficiency-wise, rather than having the buoy network, maybe just install the sonar to each ship. Would it be cheaper?
Actually, in Indonesian case, the fishermen is dominated by traditional fishermen, so they're not able to install the sonar sensor on their ship. So that's why our target is the fisherman cooperation. Usually the fisherman is make a group, so the leader of the group will tell each of fishermen where you should go, where you should go, where you should go, based on our application.
All right, thanks.
You're welcome.
ありがとうございました。それでは申し訳ありません。お時間となりましたので、以上で質疑応答のお時間終了とさせていただきたいと思います。エドワーのプレゼンテーション、これにて終了となります。皆様拍手でお送りください。Thank you very much for a beautiful presentation.
Thank you.
Thank you.